Hi friends, previous videos we discussed about the conventional brake system and how the critical parts of the conventional brake system works. This video I am going to talk about the uh, anti-lock brake system, that is ABS, which is used in the majority of the modern vehicles. As we discussed in the previous videos, braking a moving vehicle means converting kinetic energy into the frictional energy. In the previous videos, we talked about the conventional braking system, which is deployed in the majority of the present generation vehicles. Now, let us talk about the anti-lock braking system or ABS. We have been observing some accident in the form of toppling of the vehicle. What is the reason behind such toppling of the vehicle? People says it is due to the overspeeding of the vehicle. So how such toppling happens when the vehicle is overspeeding? It is not exactly due to the overspeeding of the vehicle. It is exactly due to the application of the brakes when the vehicle is running at higher speed or beyond certain speed. When emergency brake is applied or when a sudden brake is applied on a fast moving vehicle, or a steering is negotiated when the vehicle is running beyond certain speed, such toppling happens. Why such toppling happens? When the brake is applied suddenly. So to know that one, we should spend few minutes about the motion of the wheels in a vehicle. Assume this is the tire of the vehicle and this is the road. Okay. When the vehicle is going in this direction, the vehicle wheel will rotate in this direction, that is opposite to the direction of the traveling of the vehicle. Wheel is rotated. So we can understand that the vehicle wheels will have two types of velocities. One is the velocity which comes due to the rotation of the wheel on its own axis. This is the wheel axis. So wheel is rotating on its own axis in this direction, that is anti-clock direction. So a velocity which is obtained, which is generated due to this rotation, is called the rotational velocity of the wheel. Whereas the velocity which is produced, which has come due to the movement of the vehicle in this direction, that is in the opposite direction, is called the translational velocity. So both the rotational velocity and the translation velocity are opposite to each other. So if the vehicle or the wheel has to travel or wheel has to maintain the proper grip over the road, the resultant velocity, that is the sum of this translation velocity as well as the rotational velocity, should be zero. Any difference in this between these two velocities leads to skidding of the wheel or slippage of the wheel, like this. Why there will be difference between these two velocities? Yes, when it happens, when we apply the brake on this rotating wheel, the vehicle is locked by applying the brakes, means the rotational velocity becomes zero. Whereas due to its own inertia, the vehicle still continuing to give the translational velocity due to its own inertia. So there will be huge difference between the rotational velocity and the translational velocity when a sudden brake is applied or emergency brake is applied. So during that time, what happens? The slippage or skidding takes place, which leads to accident. The accidents, such accidents mainly takes place on the slippery roads, wet roads or snow roads, or when the vehicle is negotiated a turning, because when the vehicle is negotiated a turning, the principle is that one, the inner wheel has to rotate less number of revolutions than the outer wheel, because such action is absent when during the high speed because all four wheels try to rotate with the same speed. So the absence of this difference of speed, differential speed between these inner and outer wheel leads to the accident during the steering. This is about the motion. And when it comes to the introduction of the ABS in the vehicles, actually people says the ABS principle was started in 1920. The first fully electronic anti-lock braking system was developed in the 1960s for an aircraft company called Concorde. The modern ABS, that is what we are using in our vehicles today, was invented by Mario Palazzotti, known as Mr. ABS, in the Fiat Research Center and is now standard in the very car. The system was called anti-skid, not the anti-lock, and the patent was sold to Mr. Robert Bosch, who named the system as Antilock Braking System or ABS. From 1971 onwards, the company like Chrysler, Ford, General Motors used ABS as an optional and gradually followed by all other car manufacturers or vehicle manufacturers. Now, in the majority of the countries, ABS is becoming mandatory in some of the vehicles on safety grounds. Let us have a look about the ABS, how it works and its circuit. This is the symbol of the ABS which you can see in all the vehicles. This itself indicates releasing and holding. You observe this figure. This figure indicates the vehicle without ABS. So in beyond certain speed, if you want to avoid collision of this vehicle, he cannot do, because the differential speed is not maintained by between the inner and outer vehicle, whereas the machine fitted with the ABS can negotiate this curve and avoid the collision of this object. This is how ABS functions. This is another clear example between ABS and non-ABS. These two pets are being taken by a man. See the difference in behavior of these two pets. One pet is walking slowly as he is pulling very nicely, means releasing and putting his footprints, it is releasing and putting his footprints on the sand, so safely walking, whereas this fellow is a little bit, either he is lazy or adamant, whatever may be, he is not walking. Whereas he is not walking, he is forced to pull with this rope and he is slipping there. Okay? So this fellow is prone for injuries to his body, whereas this fellow is walking safely. This is how the rotation of the wheel happens when the ABS comes into action. The locking and unlocking mechanism takes place automatically with high frequency when the ABS action comes into braking system. This is what happens in the ABS exactly. Looking into the ABS system, just observe this closely. The brake pedal, brake booster, master cylinder, oil reservoir, brake lines, and the wheels and the caliper discs. Everything is common as in the conventional brake system. You can see this. But what are the additional items? The additional items are mainly three items. These are called wheel speed sensors. This is a wheel speed sensor. The vehicle has 4 speeds. There are 4 wheel speed sensors are fitted to the vehicle. Okay. And the second one is called the control module. It is an electronic control module. The third additional item is the most important one, is the modulator unit. How this modulator unit, this control module and these wheel sensors functions. And there will be another sensor which is not shown in this figure, okay, is a brake pedal sensor. Okay. So what these sensors and electronic gadgets will do, and for information, all these electronic gadgets will get the power from the battery source which is fitted in the vehicle. So what happens here? See this process. There will be some input devices and there is a processor which takes the signals from input device, process it and gives signals to the execution gadgets, executing agent. In this case, the input devices are wheel speed sensors, that is number one. So the second input sensor will be brake pedal sensor, which indicates the movement of the travel of the brake pedal. The processor, as I told you, is the control module. This is the brain of the ABS. And these are the executing agent. This is the modulator valve. So what happens, I'll tell you, explain you in brief about the functioning of the ABS in this circuit itself. This fellow sensor always keeps sensing the speed of this vehicle. It senses the locking of the brake immediately, that is slowing down the speed immediately of a particular wheel, and send the signal to this electronic control module. So this electronic control module send the signal to this fellow modulator unit. Yes, it is the time to decrease the pressure in this line and allow this fellow to rotate little bit instead of stopping completely. That is stopping and allowing the wheel to rotate, again stopping and allowing the wheel to rotate. This kind of pulses action happens nearly 30 times per second. So that due to this pulsing action, that is holding and stop, holding and releasing the wheel, allows the wheel to have some grip on the road and rotate instead of skidding on the road. That's what we have seen in the earlier slide, where the two pets, one pet was completely skidding on the sand and the other pet was walking with its legs. This is what happens when the signal comes from the modulator, releasing and allowing, releasing and allowing. That how it happens we will see. This is the wheel sensor. Every wheel is having a kind of a gear wheel. It is called reluctor ring or gear wheel. The presence of this teeth surrounding the gear gives the pulses signal to this sensor. So the pulses, speed of the pulses will be depending on the speed of this wheel actually. So that signal goes to the ECU, electronic control unit or electronic control module. It looks like this. This is the wheel speed sensor and this is called reluctor ring or the tone ring, whatever may be. Here the wheel is fitted. This is how electronic control module looks like this. When you open the electronic control module, this is the circuit board. This is how modulator looks like this. There is a pump, runs with battery, with motor, and these are the solenoid, various solenoid valves having internally in this modulator valve, front left solenoid valve, front right solenoid valve, rear solenoid valves, these two solenoid valves. Then solenoid valve relay will be there. Okay. Return pump motor. This design depends upon the vehicle manufacturer design. So modulator to ECU connector, it will be there like that. When you dismantle one type of the modulator, it looks like this. This is the block. There will be pump inside. This is the pump which will be moving due to the rotation of this electric motor. This pump always keeps sending the supplies to this through these solenoid valves. These are the solenoid valves, various solenoid valves. The signal comes to the ECU. From here the solenoid valves are actuated. Depending on the signal from the ECU, the amount of the oil to be released to that particular line is decided by these solenoid valves. That is the main function. The amount of the oil released to that particular brake line is decided by this solenoid valve by getting the signal from the ECU. So these accumulators are here to kind of to minimize the vibrations during the ABS applications. These are the solenoid coils, these are the valves. When you assemble this, they look like this. This is the motor, inside there will be a pump, and these are the output lines which are coming from these solenoid valves. So when it is fitted in the vehicle, it looks like this. These are the tubes. This is the electronic control module. This is the complete modulator valve. Again motor, inside there is a pump. This is the block. There is a lines going and connecting to the wheels. So what happens when the brake is applied? It tries to lock the rotating wheel. As I told you, when it tries to lock the rotating wheel, signal is sensed by the wheel speed sensor and sent them to the ECU. ECU decides the amount of oil pressure to be maintained in this particular wheel, that momentarily release in the pressure or decrease in the pressure, allowing the wheel to rotate a little bit, and immediately allowing again increasing the pressure and holding the wheel. So such action of releasing and holding occurs nearly 30 times per second. That's why if we travel in a vehicle which is equipped with the ABS, we can see mild vibrations when we apply the emergency brake or sudden brake. This is how this happens. See, this is with ABS coming smoothly, and without ABS, because of the difference in the resultant velocity between the rotational and the translational velocity, this vehicle is slipping or prone for accidents. Now coming to the other query. In ABS vehicles, if the brakes are released and holding frequently, whether there will be any change in the stopping distance, or the stopping distance of this ABS vehicle is more than the stopping distance of a standard brake system. This query is there. To answer that query, to surprise, the stopping distance of the vehicle fitted with ABS is shorter than the stopping distance of a conventional brake system. How it is short in spite of releasing and holding the brakes like this? Yes, in case of the non-ABS, vehicle skidding or slipping will be there, which travels due to its translational velocity or inertia for distance, whereas that skidding is not here. The stopping distance will be comparatively less than the standard conventional braking system. And what are the other advantages of the anti-lock braking system or ABS is? The ABS will prevent the wheels from locking, that's what we discussed. Avoid skidding and slipping, that's avoiding the accidents. Safe braking application by improving the vehicle stability, importantly, maintaining the safety during the steering, decreasing the stopping distance. Whatever I explained is about a basic ABS, but in the present generation vehicles, we can see the various configurations in the ABS. Go through these 4 pages. If you have inquiries, you can call me or you can contact me through the email.